Now, we can produce magnetism with electricity. You pass a current through a coil and it turns it into an electromagnet. We can make electricity from magnetism. If you spin a magnet inside a coil of wire, you get electricity. So these three things are connected: magnetism, electricity, and movement. If we put a wire that's carrying a current in a magnetic field and we pass a current through that wire, then watch what happens. I've got a little wire here. That's all it is, a little bit of wire. It's on a couple of wheels. I'm going to sit it in between those two magnets, and then I'm going to pass a current through it. There's no electricity flowing just now. Nothing's happening. But watch what happens when I turn on this power pack here. I'm going to switch on the lamp pack. Watch what happens to the wee wheel. Using electricity and magnetism, we can produce movement. Same way that we used magnetism and movement to produce electricity. This time we're doing the opposite. We're using magnetism and electricity to produce motion. Watch what happens if I turn the wires round. Swap round the direction of the current. Turn it on again. That's magic. Here's another one. This is a single turn of wire. Now that's free to move, that little loop of wire there. And I'm going to pass electricity through it, through that little loop of wire. But before I do that, I'm going to put a magnet in. I'm going to put a magnet either side of it. And then we're going to switch on the power from this electricity supply and give it a little flick. So a combination of the current flowing through the conductor, the magnetic field, produces movement. It's a very simple electric motor. Hello everybody. Now we're very quickly going to build a wee electric motor here. Remember, we've been looking at electricity, magnetism and movement. With a combination of all three, we can build a little electric motor. So we need a magnetic field. We have two magnets here, and it's important that these two magnets are attracting each other. These two are. And so we're going to stick them on this little yoke here. So there's our magnetic field between those two magnets. Next thing we want is we want a coil of wire. And we want that coil of wire to be able to spin in between those two magnets there in that magnetic field. Now that coil of wire has got two bare ends on it. There's one there, there's one there. Those little bits of metal. Those are the bare ends that we want to pass an electric current to that coil by those bare ends on the coil. Now, it has to be able to spin, so we want a little axle here that I can feed through there. But before I do that, I'm going to put a little pin on one end. Feed it through. And put a little pin on the other end. So there is my little assembly that will allow that motor to spin, hopefully. And I'm going to pop that in a little piece of wood, and there, and then stick that on. So there's our electric motor. That's it. Now remember, we're passing electricity to these two bare wires here. Let's see how we got on. So, got my lamp pack here, and with a low voltage, something like 4 volts, we're going to pass a current into the coil. Put the lights on, you can see a wee bit better. And we're going to pass a current to the bare ends of that coil, and hopefully we will get the motor to spin. So there's the two bare ends out of focus, and we're just going to touch them. I'm going to touch them to the end of my electric motor, and hopefully, oh, nearly. My hand in the road. Come on, my hand in the road. There we go then. That's magic. So, we're just brushing these wires against those contacts. Because if they were physically connected, they would all get tangled up. It's important just to brush them against. Let's go again. That's nice. Isn't that lovely? A wee electric motor. So, stationary magnetic field, rotating coil, and it's the current in the coil that produces a magnetic field around the conductor, and those two magnetic fields interact, causes the coil to spin. Yeehaw!